Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope all of you will be fine. Today we are going to discuss two group CX disconnection, in which we will discuss about the 1,2 difunctionalized compounds and 1,3 difunctionalized compounds. These are the key concepts of this lecture, in which we will discuss along with the examples how the 1,2 difunctionalized compounds are how the synthesis of 1,2 difunctionalized compounds is carried out. First of all, we will see their retro, then we will carry out its synthesis. Two group CX disconnection. As we know, disconnection in the retrosynthesis course, disconnection is a mental approach in which we disconnect a complex or large molecule into the simplest or the smallest starting material, or these are called as synthons. These synthons are converted to the starting reagents from which these complex or target molecules can be synthesized again. So the use of one functional group to help disconnect another elsewhere in the molecule, such disconnections are known as two-group disconnections. In this lecture, we will see that a molecule containing two different functional groups in a molecule will be disconnected, but how, in which manner or in which sequence that disconnection will be carried out. To convert target molecule to simplest reagents so that it can be synthesized again in two-group disconnection, there should be the presence of two functional groups, and one functional group is required to disconnect other. As the functional group is disconnected with respect to the other functional group, here we will compare the reactivity or the presence of two functional groups in a single molecule by doing its retro-analysis. So let us understand by examples. In 1,2-dix or 1,2-CX difunctionalized compounds, here is the first example. This is the structure of a molecule which contains a benzene ring containing one nitro group, one methyl group, and an ether linkage that is at ortho position to the nitro group. And this ether linkage is attached with carbon number 2 and carbon number 1. Carbon number 1 having the aldehydic or carbonyl functional group. This is one functional group, and at carbon number 2, this carbon is attached with an oxygen atom having an ether linkage. So these are two different functional groups, and we need to disconnect one functional group with respect to the other. Now here is the question, how or which functional group will be disconnected first, and why? So first point, you should keep in mind that never disconnect the terminal functional group. Always disconnect the functional group that is in between the structure. So the disconnection of the terminal functional group is not a good job. So it would not be a good approach to obtain the synthons. So we have to disconnect the functional group that is in between the structure. During retro-analysis or retrosynthesis, we will use this type of double arrow, and we will write 1,2-di-X. This means the disconnection of one functional group in the presence of other functional groups. But here you will raise a question that we write the functional group linkage as for example CO, and we will write below ether linkage. So here we will not write that statement that which bond is going to be broken. Here, after the cleavage of carbon number 2 and oxygen linkage bond, we will obtain the synthons as shown here. The oxygen atom carries a negative charge acting as anion, and the other synthon is carbonyl group having the positive charge on carbon number 2 acting as cation. These are the two synthons which are obtained after the retro analysis of this molecule. Here, in order to synthesize this target molecule, we have to prepare, or we have to think about the possible reaction mechanism and also about the possible starting materials. So the one synthon can be obtained by the bromination or by attaching a bromine at the carbon number 2 of carbon number 2 having the positive charge. So we need to add a bromine group at this position so that bromine can act as good leaving group, and during reaction this will leave from the reagent, and we can obtain the product. Here these are the possible starting materials. Oxygen is attached with hydrogen atom, it becomes an OH group, and the carbocation that having the positive charge at carbon number 2 is attached with a bromine group. Next, here is the synthesis of this molecule. During synthesis, the first step is that we will take an aldehyde group and its bromination will be carried out. After its bromination, alpha bromoaldehyde is obtained. This reagent will react with the para-methyl orthonitrophenol in the presence of a base. Now here the base will abstract a proton and it will attack on the carbon containing the bromine. Bromine group will be eliminated in the form of HBr, and an ether linkage will be developed between the aldehyde group and the benzene starting material, which I have already told you about. Here basically this is the condensation reaction. And students, I hope you will better understand how one functional group is disconnected in the presence of other functional group. This is the second example of this topic. Here is another compound. The carbon atom, which is labeled as 1, it carries a OH functional group, that is alcoholic group, while the carbon number 2, that is attached with an oxygen atom through the ether linkage. Here are also the two functional groups. One is OH and the other is oxygen atom. Here the question is, which bond will be broken? First of all, I have told you that we will never disconnect the terminal functional groups. So the option is of the carbon and oxygen of ether linkage. This bond will break, but the question is which carbon oxygen ether linkage bond will be broken. So the question is solved. Here we have two pathways. If we break the carbon oxygen bond at position A, then we will obtain the following types of synthons. These are the two synthons in pathway A. These are again converted into the starting material, and you can see in pathway A this the second synthon, which contains the carbon number 1 and 2 and oxygen atom. This oxygen atom contains a negative charge and it will be converted into OH group for its starting material. Here two OH groups are obtained, while in case of pathway B, if we disconnect the bond between the carbon number 2 and oxygen at position B, then we will obtain this type of two synthons in which the oxygen atom is attached with the allylic or ethylene functional group, and in the second synthon, which contains the carbon number 1, which is labeled as carbon number 1 and carbon number 2. Here the OH group, here one OH group is present, while at carbon number 2 there is a positive charge, and this will be converted into an epoxide. As we know, if there is a positive charge in the vicinity of the OH group, then this converted into the epoxide, as epoxide or oxiranes are good reagents for the synthesis of different compounds. So students, you can see two different types of starting materials obtained from the pathway B. Let's see its synthesis. This is the synthesis of the previous target molecule. Here, if we think about the pathway A, which contains, in which the starting material contain the two OH group in the same molecule. Here the chemoselective problem arises, that which OH group will react with the second molecule to obtain the target molecule. Here the two possible products will be formed. In one case, the OH of carbon number 2 will react with the other molecule and chlorine will be eliminated and an ether linkage is formed. While in case of second possibility, carbon number 1 of this molecule will react with the other reagent, and we will obtain the other target molecule. Here you can see that two types of products are obtained, means the possibility of selectivity is arised, and we don't get the pure single product. So this pathway or this route for disconnection is not suitable. While in case of part B, pathway B, when we obtain the epoxide or oxirane as the starting material, here you can see only the OH of one starting material will react with the carbon, and the bond will be shifted to the oxygen atom of the epoxide, and we get an intermediate in which the one oxygen atom carries the positive charge. Here the hydrogen will be removed, and in fact this is the hydrogen shift, and it will be shifted to the other oxygen which contains the negative charge, and finally we get our target molecule, which is obtained in single product. So this is the most favorable pathway that we should think about how and which bond should be disconnected preferably. Here is the explanation of all these examples as I have already discussed, but you can also read this explanation and for your better understanding. Here is the root B showing the synthons and the starting material. Students, please read these statements very carefully in order to understand the CX disconnection. Here is the example number 3. In this example, again there are two types of functional groups. One is CN linkage and the other is CO linkage. Again, I will suggest you don't disconnect the terminal functional group. So the disconnection will occur from the carbon number 2 and a nitrogen atom that is attached with the benzene ring. After disconnecting, the two types of synthons are obtained in which the benzene ring having the NH, it contains the negative charge, and its possible synthon will be the amine NH2 with benzene group. This is aniline and it is easily available in the market, while in the second case, the second starting material is the epoxide resin or oxirane. As I have told you that if there is a positive charge in the vicinity of the OH group, it will be converted into the epoxide. Now we will discuss about its synthesis. In synthesis, the lone pair of nitrogen will attack on the carbon of the oxirane or of epoxide in the presence of sodamine, and it will form an intermediate which contains the positive charge on nitrogen atom and negative charge on the oxygen atom. After rearrangement or hydrogen shift, we will obtain our target molecule. Students, here you can see that two different types of functional groups are available, and you need to think which functional group or which bond should be disconnected preferably in order to obtain the right starting materials and in order to obtain the right steps in the synthesis. Here is the fourth example. In this again you can see that two functional groups at carbon number 1 and carbon number 2 are present. So we can disconnect as in the previous example, the bond between the carbon and nitrogen, CN bond, will be disconnected, and we will obtain synthons in which the nitrogen carries the negative charge and the carbon number 1 carries the positive charge. This will be converted into the epoxide in the starting material, and NH will be converted into an amine. Again, in the second step, one more disconnection will occur between the carbon number 1 and oxygen of the ether linkage. Here CO ether bond will break, and we will get further two more synthons. One carries the positive charge as cation and the other carries negative charge as anion. These are the possible starting materials in order to synthesize these two, in order to synthesize the target molecule. If we talk about the synthesis of this molecule, the naphthol group will be attacked by a base. This base will abstract a proton, and oxygen atom will carry a negative charge. In the second step, the epoxide will be attacked by this negative charge, and the carbon atom bearing the chlorine atom, this is attacked, and chlorine atom will be eliminated by creating an ether linkage in the second step. And while in the third step, the amino group will attack on the carbon atom adjacent to the oxygen atom of the oxirane ring, and here the bond will be shifted, and a hydrogen atom will be attached to the oxygen atom, and we will obtain the target molecule of this example. In another example, here we can see another CN bond along with the carbonyl group at the terminal carbon, or the terminal group as a terminal functional group. Here the bond between the carbon number 2 and nitrogen will be disconnected through the 1,2-diex, and the synthon which will be obtained is a alpha, which it contains the positive charge at carbon number 2, and as it carries the positive charge, so an halogen group will be attached with this, suppose chlorine or bromine, as alpha halocarbonyls are better synthetic equivalents. While in another synthon, the nitrogen carries a negative charge, which will be converted with having the nitrogen atom into the starting material. This is another example showing the 1,2 disconnection approach. While for the synthesis, during synthesis, the carbon atom number 2 having the chloro group, that is a good living group, it will attack on the nitrogen, and an HCl will be eliminated, and again we will obtain the target molecule. Here is the 1,3-CX difunctionalized compounds. Here two functional groups are present at a distance of carbon number 1 and carbon number 3. Presence of two functional groups in 1 to 2 3 relation to each other. One functional group is used to disconnect another. 1,3 disconnections arise when there is a chance of alkene conjugation to an electron with drying groups, for example carbonyl, nitro and cyano group. Let us discuss these points along with the examples. Here you can see in this example there are two functional groups, one labeled as carbon number 1 and other labeled as carbon number 3. One carbon number 1 contains the terminal functional group, so this bond between the carbon number 1 and 2 will not be disconnected. While at carbon number 3, this is attached with the sulfur atom. This is just like an ether linkage. This is thioether. This is just like an ether linkage in place of oxygen. Here is the sulfur atom is attached. So you can see there are three carbon atoms. Carbon number 1 contains one functional group and carbon number 3 contains another functional group. Here the bond at the carbon number 3 will be disconnected in the presence of the one functional group at the position 1. And we will obtain the synthons like this, in which the sulfur will contain the negative charge and The other part will contain the positive charge, and it will be converted into the possible starting materials as. Here the S is balanced by the hydrogen atom, and the positive charge of the carbon atom is converted into an alkene. And here the question or the point is clear that 1,3 disconnections arises when there is a chance of alkene conjugation. Alkene conjugation to an electron withdrawing group. आपने ये बात बहुत consider करनी है बेटा, that in the vicinity of the carbonyl group there is a chance of alkene conjugation as the starting material. More reliable 1,3 disconnections are those having nitrogen, sulfur and oxygen atom. This is example number 2. The disconnection of this example. In carbon number 1 there is a carbonyl functional group, and at carbon number 3 this is attached with the nitrogen atom in the form of a tertiary amine. In 1,3-diex, the CN bond will be disconnected and a secondary amine or a secondary amine anion is formed, while at carbon number 3 there is a carbocation is produced. This will be converted into the possible starting materials like this. And in case of its synthesis, you can see in secondary amine the base will abstract a proton from the nitrogen atom, and a negative charge is generated on the nitrogen atom, while in case of other starting material, it is converted into the alkene functional group, and here the nitrogen will attack on the carbon number 3 of the alkene, and it will give the final product like this. Here students, you can see that there are two functional groups in these molecules. So when you will do the practice, you need to identify the two functional groups in the molecule and the possible mechanism for the disconnection of these two functional groups, keeping in mind the order of events and keeping in mind about the protecting groups, that how and at what position you will disconnect, at what time you will disconnect the functional group in the presence of the other. Here is another example for the 1,3 difunctionalized compounds. Again, you can see carbon number 1, that is labeled as 1, contains the carbonyl functional group, while carbon number 3 contains the CN bond. In 1,3-diex, we will obtain these two types of synthones, which will be converted into the possible starting materials like this. Here for the synthesis of this target molecule, this is the scheme for the synthesis of this molecule. The NH2 group will in the presence of a base, this base will abstract a proton from the NH, and nitrogen will carry a negative charge. It will attack on the carbon that is adjacent to the phenyl group, that is attached by two double bonds by double bond. And you can see here the carbonyl double bond and the alkene double bond is in conjugation with each other. This is hint or a point need to be remembered, that 1,3-diex or 1,3 disconnection will occur at that position where there is a possibility to become a conjugation. So after the protonation we will get the final product as. Here is another example for your practice. Again, the two functional groups are present. One is nitrile group at the carbon number 1 and the other is ether linkage at the carbon number 3. Again, we will not disconnect the terminal functional group, and the disconnection will occur at the carbon number 3 and the oxygen CO bond. And here are the possible starting materials. While in case of synthesis, you can see a base will abstract a proton from the benzoyl alcohol, and oxygen will carry a negative charge, while the double bond of the nitrile functional group, or the nitrile starting material containing the nitrile, will be attacked through this oxygen and an ether linkage will be developed. So students, when you have a molecule, first of all carefully and thoroughly watch at that molecule what type of functional groups are present in it and at what position of these functional groups are attached to each other or linked to each other, so that you can easily identify which type of disconnection can occur in this molecule. Here is the assignment for you. You are required to do the retro analysis of the given compounds along with the synthesis. Carefully you should identify the two functional groups with respect to each other, either 1,2 difunctionalized compounds or 1,3 disconnection. So please do practice of these three molecules and let me know if you find any difficulty or problem during the retro analysis of these molecules. Except this examples or this three examples in the assignment, you can also do practice in the some other books. For example, in these are the recommended books: The Disconnection Approach by Stuart Perrin and The Organic Chemistry by Claydon and Greaves. Thank you so much. Allah Hafiz.